Good morning, everyone. Welcome to today's webinar. As we all are aware that the demand on spatial data science skill is increasing. So many universities start offering programs and courses related to spatial data science. So we would like to bring that topic today, sharing experiences in teaching spatial data science. But before we start, a little bit of housekeeping. All attendees are in listen-only mode, but feel free to write your questions in the question windows at any time, and we will try to cover as many as we can during the panel discussions. Also, the session is recorded, and we will make the recording available to you later. At the end of the webinar, we will launch the exit survey. So please do participate on the survey so you can help us improving our webinar, and it's also a good way to connect with us at Esri. Before we start, we also like to understand a bit of your backgrounds of the attendees today. So we would like to ask you a couple poll questions. Let's open the first one. And the question is, what is your primary role? Now, this is a single choice question. I know many of you have a lot of different roles, wearing many different hats, but this one, choose the main one, your primary role. All right, I think we get majority, so let's stop that and share the result. It seems like many of you are teaching professors. Right on, this is the target audience for us. Thank you so much. Now, and the second question here, that's a follow-up questions, is we would like to ask you, because this is a webinar about teaching spatial data science, we'd like to ask you, are you running a spatial data science program or teaching courses related to spatial data science? Seems like 59% of you saying yes, and 19% of you say it is in the plan. So awesome. That's really the one that the target audience that we would like for this webinar. Thank you so much for your participation in the poll session. Well, we have an exciting group of presenters for today's webinar, 3 from academia and 2 from Esri. So let me introduce them. First one, we have Dr. Trislin Nelson, who joined the Department of Geography at the University of California, Santa Barbara as a Jack and Laura Dangerman Endorsed Chair of Geography. Dr. Nelson joined UCSB from Arizona State University, where she has been the director of School of Geographical Sciences and Urban Planning. Prior to that, she was professor and director of the Spatial Pattern Analysis and Research Lab at the University of Victoria, Canada. And her research interests to include the spatial temporal analysis, active transportation, and the use of big data and analytics. The second presenter is Dr. Song Gao, who is the assistant professor in geographic information science at the University of Wisconsin-Madison, where he directs the Geospatial Data Science Lab. His research interests include the spatial or geospatial data science and GeoAI, the approaches to human mobility and social sensing studies. The third presenter is Dr. Ilya Zaslavsky, the Director of Spatial Information System Laboratory at the San Diego Supercomputer Center, the University of California, San Diego. His research focuses on distributed information management systems, in particular on spatial and temporal data integration, geographic information system, and spatial data analysis. He is the pioneer to teach the spatial data science at UC Santa Barbara for the last several years. Fourth presenter is Dr. Lauren Bennett, who leads the spatial analysis and data science software development team at Esri. In this role, she oversees the research and development of the ArcGIS analytical frameworks, which include the spatial and spatiotemporal statistic, multidimensional analysis, machine learning, and big data analytics. She directs the releases of new spatial data science capabilities across a wide range of products and applications at Esri. Last but not least, myself, I'm Kanserina Kurnia. I'm a senior solution engineer at Esri, and my main role is providing technical advice and assistance to universities. And I'm also leading the spatial data science outreach to education community. So in my role in this webinar is more as a moderator. For the agenda, what we're gonna do is we're gonna start with each speaker present their program, introduce their program and courses related to spatial data science, and also their thought, challenges, and some advices. And after that, together, we're gonna have panel discussion. So feel free to participate by posting your question, and we can include them during the panel discussions. With that, I'm gonna stop sharing, and without further ado, let's hand it over to Tricelin to start.
Okay, thanks so much for inviting me to participate in this panel today. You know, a lot of my experience really comes from a programmatic level. So I wanted to just start out by sharing some of the different programs that I've been involved with, just to give you a sense of the sort of breadth of programs I've worked with. So the first is when I was at University of Victoria. I was director of the Geomatics program. So Geomatics, I think, is a Canadian word for a combination of GIS and remote sensing. And this was a degree that was combined with computer science. So it was a small, but I think pretty powerful program. At Arizona State University, we had a variety of programs really at all levels. And we had a BS, C in GIS that was both offered online and on campus. And this, by the time we had been operating the online program for a year, had over 200 students involved in it. We also had a master's in GIS, and I was involved with a campus-wide sort of effort to launch a data science degree with an emphasis in spatial data science. And now at UCSB, there's a number of GIS science programs there and data science programs as well. And I think there's a lot of emphasis placed on the PhD program. So just a range of experience. And I wanted to share kind of some of my thoughts about when you set up these programs or manage these programs, what are some of the things that you need to consider? And so I'll just provide comments on these 4 areas. So the first is that, you know, across all the programs I've been involved with, the audience and the size has varied quite a lot. So in some cases, we've had, you know, small boutique programs that maybe have 30 students, and in other cases, the goal was really to scale a program to a really broad audience. If you're setting up one of these programs, I think thinking about who it is that you're trying to educate and how and at what scale this is going to be optimal, I think is really important. And as you make those decisions, I think it'll change whether or not you want to do your data science degree totally within one department, or do you want to have it combined between, you know, a geography program and a computer science program, or geography and statistics, or all 3. I think that those, you know, as you incorporate more departments, in my experience, it makes it harder to scale. So if you want to have 200 students, you probably want to think about doing it more within a single program, unless, you know, you have very strong relationships with those other departments. Maybe you're at a smaller university where it's easier to interact with your colleagues across departments. That might work. But what I've generally found is that as these programs scales, it gets easier to do that if you're running them out of a single department. The second thing that comes up consistently is, where do you teach programming and statistics? So if you are running a spatial data science program out of a geography department, teaching programming and statistics can be challenging, sometimes from a faculty resource perspective. And it can also be challenging to teach these concepts online if you're going to be thinking about doing this in an online way. And so in some cases, we've partnered with computer science and statistics departments. In those cases, I would say, you know, there are opportunities and challenges to going in that approach. Again, we have found that our students often like to have a GI science specific version of these techniques when they're doing spatial data science. So sometimes we have found it easier to pull those back in-house. But it, you know, it's really something to think about. I think that this is sort of the sticky part sometimes of the success of these programs. The third thing I think that we need to be considering about is what prerequisites require, and do we need all the prerequisites that we have maybe used traditionally. So, you know, as students go through programs, you know, any kind of STEM-based program, We tend to see that classes build off the classes before, which is great because we want deep knowledge. On the other hand, when we add too many prerequisites, it can be a real barrier to students being able to enter these programs. And as we think about trying to diversify the workforce, we need to consider what are the impact of prerequisites that might be unnecessary or that don't have enough flexibility that students can enter the program in a variety of ways. So we can't just design programs where students knew in grade 11 that they wanted to be doing spatial data science, and it's really hard to catch up if they kind of missed some of those early prerequisites. We need to find multiple points of entry. And then the last thing I would say is that, student recruitment can matter a lot. And we have found, depending on the program and the audience, different ways of doing this. Often, if you're trying to attract students to a spatial data science program, I would suggest that you think about who are the students in computer science or engineering that are maybe looking for a more applied opportunity. So we have often found students who are, maybe finding those too technical or those programs too technical or theoretical. They sometimes really like the applied nature of spatial data science. And so some of our best pipelines have come from those programs. So if you're at a university that's trying to boost your enrollment, that would just be something I would consider. And that's it for my comments. I'm looking forward to hearing from my colleagues, and I'll see you in the question and answer.
Thank you, Tristan. Well, your experience in spatial data science program in several universities really helped to get the clear picture on the challenges and thoughts on decision to run a similar program. Thank you. Let's hand it over the stage to Sango.
Great, thank you. So today I would like to share my experiences in teaching spatial data science at the University of Wisconsin, Madison. Um, so 2 years ago, our university launched a new data science major, and within this data science major, we add a spatial data science curriculum within this major. It offered both in residence and also online. And so as you can see, there are some core courses traditionally from computer science and statistics, which teach students about the foundation of data science, and including like introduction to data modeling or data science programming with Python and machine learning. But you can also see that at the elective level, they also added those courses which are taught by geography professors, such as I'm teaching the advanced geocomputing with geospatial big data analytics, and my colleague Professor Huang teach geospatial database design, and also another cartography professor, Rob Ross, teach interactive cartography and geovisualization. So all those geographic or GIS-oriented courses are offered in this new data science major. Also, show the importance of the spatial data science curriculum design in the general data science major. So what we teach in this class actually centered at the spatial thinking and spatial analysis. So this is actually like a web book provided by Cato, which share that based on their current curriculum and in the market, and contain 4 important components like based on the programming. 2 most popular data science languages might be Python and R. So a lot of geospatial analysis tools and packages also center at Python R. And in addition to that,
I think we lost the connection. While we fix and then help Songo to fix this, maybe we can start with Dr. Ilya first, then we go back to Song. How about that?
Sure. It's a pleasure to be here, and thanks, Esri, for inviting me to share my experience. My name is Ilya Zaslavsky. I'm a researcher at San Diego Supercomputer Center at UCSD and director of Spatial Information Systems Lab. My background is in geography and GIS, but for the last 20 plus years, I've been working at SDSU on various data infrastructure projects. So when I was asked to develop a spatial data science course, and that was more than 3 years ago, I took this as an opportunity to take those concepts and approaches from traditional GIS curriculum that I found most useful in my own work and organize them into a series of problems that data scientists are likely to face when they work with spatial data. So this is how my spatial data science course is set up. And last year it was also followed by a group study and independent study courses, mostly focused on COVID. What is special about this course? This course is for data scientists. Data science programs are growing rapidly all around the country. They have massive enrollments, and it's a very popular major. But spatial data science curriculum for such students is just emerging. The students haven't had traditional cartography or spatial analysis classes. They don't know these concepts, and most of them don't even know what Esri is. But they have had 2 years of Python and machine learning and statistics and probability classes and sometimes image processing. And they also typically write code better than I, or at least faster. They're also very much focused on learning practical skills through projects. So in this course, I replaced coding homework assignments with open-ended mini projects where students experiment with different data that they find themselves and come up with their own solutions. Machine learning libraries such as scikit-learn, students already know, and many of them have experience with Keras and TensorFlow. So on the spatial side, we cover both open source libraries such as GeoPandas and PyCell, and commercial systems such as Esri's ArcGIS API for Python. Something that has been extremely beneficial for us, especially in the first couple of times I taught it, was the opportunity to directly interact with Esri API developers. As you can imagine, when 50 students hit an API as rich and complex as the ArcGIS API, in a non-prescribed manner, many interesting things can happen, and we share results with Esri. So the next series of slides, I will not go through them in detail, but I want to demonstrate how we start from what students know, such as pandas, which they learned in previous classes, and then we go through critical thinking and coding practice to new concepts that are spatial concepts. So, for example, from pandas, we move to GeoPandas and discover that when you plot several geodata frames, they may not align. From here, we move to projections, obviously. Then we discover that topological operations don't work as expected, and this may be due to geometric imperfections and uncertainties inherent in spatial data, which leads to discussion of data quality and spatial metadata, and then to topological data structure. So this is a way to go through GIS curriculum and introduce new concepts when students see by themselves that something doesn't work, and that encourages them to explore things by themselves. So after GeoPandas, we move to ArcGIS Python API and ArcGIS Online and see how spatial data can be more generally handled as layers, then move to raster data and suitability modeling, and to key concepts in spatial statistics. And throughout the entire course, students apply machine learning techniques to the data frames that they construct themselves using geocoding, geoenrichment, and various spatial operations. There's a new GIS for Science book out now in print form, volume 3, and it has a chapter about this class, which describes all the assignments and projects in detail. So now I'm actually rewriting all mini project instructions so that not to repeat what is already published in the chapter. Here's a fairly typical feedback from a student after a summer internship. So knowing how to deal with spatial data helps students stand out in their teams, because more and more projects deal with spatial data of different types, and that gives them an advantage. Finally, all student projects with their Jupyter notebooks are organized as a public group on ArcGIS Online, and you can find them when you search ArcGIS Online. And here I show some projects done recently and focused on COVID-19. At least 2 of them are done by students who continued working with me after this class. And these projects have a longer life. One is a self-updating COVID dashboard. It actually automatically updates daily. It won the first prize in the ERISA competition last year. And another is a spatially explicit agent-based model of COVID transmission in schools, which uses real school floor plans to model spatial distribution of infection risks and relative efficiency of different non-pharmaceutical and pharmaceutical interventions. In summary, the focus on open-ended practical problems with real data, and especially in socially important problems, is what makes this class enjoyable to both students and myself, and as I hear from them, useful. All this information is online. If you are interested in learning more, email me. Thank you.
Thank you, Ilya. In fact, we actually put it in the chat already, the link to the Teaching Spatial Data Science and Deep Learning that is in our geoscience book. Thank you. Thank you, Ilya. It's interesting to hear the Teaching Spatial Data Science in the data science program itself. And I always love to see your student project. They are always very interesting. And glad that Esri can help. So for our audience, if you need help from Esri as well in running your program, you are more welcome to contact us on that. And it seems like Songo is back alive now. We're gonna hand over back to you, Songo, to continue your presentation. Thank you.
Okay, yeah, sorry about that. Yeah, because of the internet interruption. And I just need 2 more minutes to finish. And one of the biggest challenge when I teach, both from geography elective student or the data science elective is that because they have different purpose. So for the geography elective students, they want to more in the practice or learn new programming skill or emphasize or reinforce some of those spatial concepts, what they have learned through geography curriculum. But for the data science, students, they may already have some fundamental programming experience from prior fundamental class. So they are looking for some, domain-specific, application-driven to solve real-world problems. So this is why when we design those spatial data science curriculum, we may want to address, both groups of the needs. So that is, I think, is a very interesting part, but also might be some potential challenge in teaching spatial data science for this, new program. So some of the, experience I'd like to share is that first of all, we have to acknowledge the differences among the different types of students regarding their thinking style, the knowledge background, and also the skills they already have. And also, no matter from each type, they all want to engage with real-world problems and applications, and also they love the coding examples also shared by 2 other colleagues. And I also would like to share that Esri also provide a very useful, educational guide for their teaching for spatial data science. I believe the host also share in the handout. I think you may actually check it out, which may help you design your spatial data science curriculum. So that's all for me. Yeah, thank you very much. I'd like to discuss with you more later in the panel discussions.
Thank you, Song. Before you disconnected, I'd say that it's really nice to see here that your spatial data science blended into the data science major itself. And I think we all can relate as well the challenge to address 2 different groups of mindsets here. Okay.
Yes.
And also glad that you mentioned the resources there. And then we will share the resources, including the one that you mentioned, with the rest of the audience. Okay. Now, last but not least, let's hear some thoughts from Lauren Bennett. Lauren, time is yours.
Hi. Okay, well, I want to talk about something that is very important to me, which is this question, are GIS analysts already data scientists? And I think that it fits in nicely to this conversation because I also, in addition to, I love seeing the ways that geography is being incorporated and spatial is being incorporated into kind of traditional data science programs. But I'm also really passionate about the fact that there's this world of GIS analysts who understand spatial already, who should be playing a key role in massive data science projects at their organizations all over the world, right? So we have this place, and the best, in my experience, the best analysis gets done in kind of collaborative, multidisciplinary teams, and bringing in the value that that geography can bring is really, really important. So in kind of answering this question, I started by thinking about, well, what does the GIS community do? And one of the big things that we do as the GIS community, well, what we do is we solve the world's most complex spatial problems. And we are really good at applying kind of a myriad of tools and approaches, and we tackle this diverse set of problems. And we really focus on kind of finding the best method or approach for a particular problem. And I think one of the things that gets a lot of students into geography, I know it's for myself what made me fall in love with geography, is that we work across domains and industries. So geographers really have this particular viewpoint, but we apply it to all of these different areas. It's kind of inherently a multidisciplinary field. And that really puts us in a really good position to participate in these big data science projects and to be data scientists. So we know what the GIS community does. Well, what is a data scientist? I think it's hard to answer that. You cannot look on the internet and ask the question, what is a data scientist, without seeing, I don't know, 150 different Venn diagrams. That seems to be the only way to describe a data scientist, is with a Venn diagram. And they all look something like this, right? It's some combo of stats, programming, and subject matter expertise. Now, I would argue, and one of the things, this is one of the kind of first Venn diagrams that's quite popular. And I loved this quote where Drew Conway originally introduced this Venn diagram, but he kind of says that, you know, this data plus math and statistics, you get machine learning, which is great if that's what you're interested in, but doing data science is all about that science piece, right? Science is about discovery and building knowledge, which requires some motivating questions about the world and hypotheses that can be brought to data and tested with statistical methods. And I think that this idea that the science has to come into play and that it's about these motivating questions is really a place that we as geographers can shine. This is actually one of my favorite ones in terms of these Venn diagrams. It's a lot of the same stuff. It's still programming, it's statistics, it's in this case business, but that's really just the subject matter expertise. It brings in communication and storytelling, which I actually think is one of the places that spatial data science particularly shines, because maps are this incredibly powerful tool for communication, for taking really complex, sophisticated analysis and helping people understand it and turning it into something very tangible and real, because you know, people see where they fall on that map, and suddenly this analysis that you've done really means something to them, very personal. The other thing that I think is obvious when I look at this Venn diagram is that nobody really falls into the center of this. There's no such thing as a perfect data science. You can't know everything, right? I mean, by this logic, a data scientist is someone who just knows everything, and we know that that's not really possible. So we have to collaborate with each other. And I think one of the things that I really have seen, and I would like to see more of, is us empowering folks that are GIS analysts or that see themselves more on the GIS side to see themselves also as data scientists, because most of these GIS analysts, they also already know Python, and they also already know a lot of sophisticated spatial problem solving. And so they're data scientists already. You know, they may not know everything, but of course they don't. No one does. And empowering them to see themselves that way, I think will have a huge impact. Now, within ArcGIS, we think about spatial data science as this kind of building blocks. We've got data engineering, how we prepare our data. GIS and geography has a huge role to play there, right? It's about bringing spatial can often be the thing that connects our disparate data sources and allows us to, connect things together and do that data engineering so that we can go on to do the complex, sophisticated modeling. Visualization and exploration, which of course happens across the entire data science process. Then we kind of break out spatial analysis, machine learning and AI and big data analytics, which I'll talk about in a second. Of course, there's modeling and scripting, and then sharing and collaboration. Things like story maps, which maybe don't seem like data science, I think are one of the most important things that we've done in the last decade when it comes to spatial data science, because it's really about that final 10%. You could do a great analysis, but if no one can use it to do anything, what's the point? So being able to tell a story about your analysis and turn it into action is really critical. I would say that the kind of final piece I want to talk about is that we do break up spatial analysis, machine learning and AI and big data analytics, because for one thing, we want to make sure that that these are big area, that machine learning and AI and big data analytics are huge areas of research and development for us, and we've got a lot invested in furthering our work in those areas. But the reality is, I'm looking forward to the day that we don't have to kind of break them apart. That's just analysis, and I think there's a lot of kind of focus on. And I've seen it for sure in a lot of students. It's like, well, I want to use machine learning. It's like, well, why don't we focus on the problem that we want to solve and use that as the basis for figuring out what the best methods for doing analysis is. And if we focus too much on, we've got this hammer and it's machine learning or it's AI or it's, a suitability analysis, it doesn't really matter what it is. Everything we find, everything we do will start looking like a nail, right? And so we really want to be focused on helping students understand how to break up big, complex problems into small, answerable questions, and then focus on finding the best method to solve that, to answer that answerable question, and build that up to big answers to these complex problems. And of course, we're working kind of across the board on the different areas where you can solve those problems. But I really think it's important. First and foremost, you're never going to learn in school everything you need to know when you go to solve these problems. The most valuable thing that we can teach these students is how to break things up into those problems and questions, and then how to find the best method to solve the problem, and not to, let's say, be swayed by the buzziest, newest, sexiest thing that's going on, but really on the thing that really most appropriately solves their problem, which I think is very easy to get pulled into. So that's my take on how what we want to be talking about when it comes to spatial data science. I think there's a lot of opportunity there.
Thank you, Lauren. I really agree that, the GS professional is also spatial data scientist, because we do sophisticated modeling and analysis. And I think also the most important is start with the problem to solve, then finding the best method to solve the problem, right? So thank you. Okay, thank you so much to all the presenters. I think we all agree that we already learned a lot from our speakers. Okay. But now we are ready to move on to the next segment of this webinar, which is a panel discussion. But before we do that, we'd like to ask you the third full questions, actually. So the question is, what's the hardest skill to teach in spatial data science course? Okay. Now, this is a multiple choices. And it's targeted more for those who are currently teaching the courses related to spatial data science. Okay, I think we can close the poll and we can share the result. It seems like 49% of you say programming. Okay, I think it's resonate well. But second is the spatial statistics. And then equally, a little bit less in machine learning as well. Okay. Interesting. Thank you so much for your participation. It's very good here. Thank you. So let's start with the panel discussion with all the presenters. We welcome you to put your question in the chat as well, so we can include that in the panel discussion here. So I'm gonna start with a basic question first, and I think I'm gonna give this to Trislin and Song. Why should the geography program be teaching the spatial data science? What do you think, Trislin?
Well, it's funny, as I went through my degrees over time, I sometimes would come up against a problem that I would struggle with technically, and I would wish, oh, I wish I had got a degree in statistics, or I wish I'd got a degree in computer science. But then when I became an assistant professor, one day I was sitting in my office and my good colleague and friend came running down from the stats department. He was, Trislin, I've got $25,000 which we can give to a student, but we have to come up with a question related to forests. And he was sitting up in his office struggling with how he was going to come up with a question related to forests. And all of a sudden I realized that my training as a geographer, which I think ties into some of what Lauren was talking about, where I don't know everything. Sometimes I don't know things as deeply as I would like, but I'm really good at integrating teams of people who have different kinds of knowledge and bringing, a variety of solutions to a problem that we frame in a spatial way. And so I think that, geography has a role to play in, leading education around spatial data science, in that, we are solutions focused. Many of the problems that the world is faced with right now, I think really require that integrated lens that geography brings. So yeah, so I think it's a good integrator of many skills and techniques.
Oh, thank you. Yeah, I think this totally makes sense, and we all agree with that. How about you, Song? Would you like to add on that?
Yeah, I also agree with Trislin about what he said, and also about Lauren's comments. Yeah, GIS analysis already a data scientist, so this is why, when we teach the spatial data science curriculum, originally actually we already teach the geocomputation, series of courses. So then, because of the new data science major, we, different departments start talking, right? What kind of courses can really serve the data science curriculum? So my feeling that on campus, we really need to talk with other departments, faculty members, and especially during the planning of the new curriculum or new major. I think that's really helps. For us is really because we feel ourselves already, data scientists. So we want to reinforce, such campus not only within geography but also cross campus. So this is why we want to put our courses into this, curriculum. This is why we want to reframe as a spatial data science, series. And that's
Interesting.
my.
Thank you. Yeah, that's your talk on hand, right? So if we move now to Ilya, you are actually teaching the spatial data science program in the data science itself, right? Okay. So, do you think that's how you actually approach that data science program to really pay attention to the spatial component that able to include your course in that UCSD data science program?
That's a good question. I hope the answer is yes. And when students develop their final projects, we typically invite people from industry, from academia, from Esri to look at these final projects and assess them from the perspective of whether they demonstrate sufficient spatial thinking and spatial modeling and spatial analysis skills. And so far it worked quite well, I should say. I want to very quickly address what was just discussed, because I agree with what Trislin and Song just said, but I don't think we need to convert geographers or urban planners or other domain specialists into expert coders to do geoscience. In fact, projects and research projects are done by teams. If geographers can formulate problems in the terms that would be understandable by data scientists, if data scientists can take these problems and convert them into, chop them into building blocks that they can convert into a workflow that they can implement in code, that probably would be, that's how we will probably achieve our goal. But a lot depends on the background and the types of students you teach. If they don't want to code or have difficulties, it's very difficult to make them. If but there should be some way to converge in the middle. In fact, we started to create teams that would be composed of data scientists and urban science and planning students. We don't have geography department in our university. It was sort of slowed a little bit by the pandemic, but the idea is that everybody, one group will bring domain expertise, another group will bring computer science and data science expertise, and in the process of conversations, they will figure out how to chop the problem into executable chunks and solve it.
Thank you, Ilya. That's really, really nice advice from you on that. I pick one question now from the audience here. Probably I'm gonna start with Lauren for this one, and then pass it to our academic colleagues. How do you differentiate between spatial analysis, spatial statistics, and spatial data science? Okay. And for Ilya, Song, and Trislin, how do you actually address that in your course? So what do you think, so, Lauren?
I guess, I don't really, honestly. Spatial analysis to me is the overarching, spatial analysis versus spatial data science are completely interchangeable terms as far as I'm concerned. We could try to break it down, but it's like, even I loved Ilya's point about, we don't need to turn all geographers into computer scientists. And I love that, because I'm definitely not a computer scientist, nor will I ever be. And that's okay. I think there is a middle ground where, maybe folks don't become expert programmers, but I do think understanding the methodologies that underlie data science is critical, because if we just say, oh, I'm going to pose the problem about forestry, but I don't know anything about the analytical methodologies, then it leaves the data scientist to go off and do, frankly, like a very non-spatial analysis of a very spatial problem. And so I think that there is an intersection on the methodology where, maybe a more traditional kind of computer science-y data scientist and a more geography-centered data scientists meet in the middle and are in methodological classes together. They're learning the underlying assumptions of methods. They're learning about why spatial matters and how it can, break the rules of certain statistical assumptions and those sorts of things together, so that then they can work together and still be bringing the other subject matter expertise that they have to bear. I think that this, I've met with a bunch of data scientists at big agencies. It's like, oh, how long have you, been doing what you're doing? It's like, I've been doing this for 20 years. It's like, I'm a data scientist as of, 2 years ago, but literally I've had the same job, been doing the same work, been solving the same problems. Like, it is in a lot of ways a rebranding. Like, it's analysis. It's just science, right? We have a question, we have a hypothesis, we bring the best tools that we can, we use the best tech that we have, and we solve the problem. And that's what we've been doing for centuries. So I'm not saying there aren't new things about it. It's just that I think there's some unnecessary lines that get drawn that I don't know help us actually push further along and solve these problems any better than we would if we didn't draw those lines.
Do you make it the difference really when you put it in the data science course? Maybe Song or Truslin or Ilya want to pick on it?
Actually, I agree with Laura. So I think Laura made a great comment. I think they are all intersecting, but as I mentioned earlier, for the students, they come from different backgrounds. So this is why they may have a different domain expertise emphasis, but they are all, coming together and have an intersection. So this is also a cool thing about the interdisciplinary courses.
Yeah, that's true. How about you, Ilya?
There is certainly a big overlap between spatial analysis and spatial data science. When it gets to visualization, when it gets to data preprocessing, but then when you are trying to build models, there is certainly a set of specialized techniques that come from data science that spatial data scientists should understand and should know their limitations, should know what type of accuracy they would get, should know how to tune them, how to teach them this skill without much coding. I don't know. In fact, in winter, I will be teaching my regular course for data scientists, but then in spring, I will be teaching in a graduate program for students who do not have that much computer coding, coding background. Also, the course will be called Spatial Data Science, but I understand that I will not be able to give them these exercises that I give in my previous class, and also I will need to refocus on helping them understand what these techniques do and how you extract insights from the data, sometimes big amount, large amounts of data, and how you tune those insights. And this is where the main challenge is, I think, for those who teach spatial data science to geography and other more traditional students.
That actually brings to the question from the audience is actually, what is the best approach to teach the spatial data science course to students without any background in programming or in statistics and only taking the basic GIS course? Are prerequisites in programming or statistics always recommended? What do you think? I'm probably going to pass it to Treslin first, maybe, on this one.
I think I think that's actually the rubber meeting the road question in terms of the logistics of offering spatial data science. And so I think you have to decide who your audience is. If your audience is basically users of existing software, then no, they don't have to be able to program everything. They do need to know enough about programming to do what I think Ilya is really talking about, which is communicate with folks that they need to work with to do sort of more advanced analysis or customized analysis. So you need that language. Statistics, from my perspective, I think, you have to have enough that you can understand. Even if you're not the one running the stats, you have to be able to interpret them. So I think, I would say you need some background in that. The one thing is so that's one audience. I think the other audience is someone who's, a little bit deeper into the actual analysis and tool building. And then I think you have to spend the time to get some of that background. And one of the things in the last round of sort of answers that really came to my mind is, so my own path, I thought I was going to be a band teacher. So you can imagine, as I found GIS later, I had a lot of catching up to do. And in some areas, I'd say I probably never caught up all the way. But the thing I noticed is as I gained skills, even if it was a bit of programming, I programmed in R because it was the thing that had lots of add-ons that were good for someone like me who was just starting. But each time I got some more skills under my belt, I got more confident and more creative. And so when Lauren talks about, we don't want everything to look like a nail when you have a hammer, I think it actually helped me overcome that a bit because I was more creative in, even if I was just borrowing other people's code and stitching it together, I could customize things to do what I wanted to do, to push a little bit. And so I guess even though I think sometimes we don't want to teach those things, I do think we want to be getting some exposure into our students around those concepts.
It does important, right? And how about you, Song? You're the one that have these two domains, interests and two background students. How do you merge them together?
Yeah, so for us, I think we actually design different level of the courses. For example, at the intro level and the advanced level. For the intro level, a lot of students actually they are just want to know the spatial analytics, so they want to just use tools or learn the the tools and the knowledge behind that. So it's more about teaching them about those concepts and then what kind of methods they can use for specific problems. But for the advanced courses, we emphasize more. You are not only tool users, but you are also tool makers. So you want to learn some of the data engineering or tool development using programming. So this is why in the advanced courses we actually we don't use like a user interface tool directly, but we actually emphasize. For example, you can still develop or utilize some maybe spatial autocorrelation analysis, but through Python or R. But you can also create a new methods, design your own method, design your own function, design your own classes, and then put them integrated with QGIS or ArcGIS or other platform. So I feel that they really actually very excited about this, because they feel that actually they are not using the existing tool, but they are able to contribute back to the suite of tools. I think the students are really excited about that.
Okay, so I think it's important to make student exciting but not get frustrated, right? It's just like go into the levels that they want. Okay, and I think that's probably Ilya that's gonna teach that more non-programming students in spring. That will probably help as well. We have another very interesting question from the audience in here. Yeah. Can the panel address a growing issue with GIS, which is an identity crisis? I am often at loss when talking to data science people. Is GIS now geospatial spatial data science or geographic data science? My sense is the GIS field is now playing catch up on several fronts. What do you think? Lauren, okay, Tristan first, go
Lauren,
ahead.
do you want to go first? I know you have things to say on this.
I wrote a paper about this in my undergrad. I mean, geography has always had an identity crisis. It's like the nature of geography, because we're a field that's very specific, but also this big multidisciplinary thing. It's why some schools don't have a geography department, but there's a big GIS lab, and then it's just tools. Or there's I guess to me, there's nothing new about this identity crisis that is happening, and I don't think that we are playing catch up. Honestly, I think that we are a contributor in a massive, very exciting time where we're solving problems using new tools, and we have very important knowledge to bear on that.
I think I want to kind of give whoever asked this question a hug, because I sometimes I call myself a spatial data scientist.
Mm-hmm.
Sometimes I call myself a spatial analyst. Sometimes I call myself a quantitative geographer. It kind of depends on what audience I'm talking to, which one I think is going to connect with them. And so I think that the challenge is, and Mike Goodchild, I've heard him say this, it's that it's the challenge of GIS, of defining it, is that it's actually everywhere. That 80% of big data are spatial data. So we're really splitting hairs when we talk about spatial data science as opposed to just data science. And I think that those things are going to converge. So the thing I would say about GI scientists is that I think that it's actually up to us to raise our voices, to stand up and lead, to be outward facing to our communities, to talk about the things that we do, and to not just follow behind, both in science generally, in data science specifically. So I actually think we're doing the right things, but sometimes I think we just aren't used to being the ones that are leading. And so I think it's kind of on us to make that argument.
Okay. Well, go ahead, Ilya.
I would say that whether you consider this as a crisis or as an opportunity, it's a matter of choice, right? Because it's very interesting to be, flexible, and as Trislin mentioned, have many different hats and wear them when is needed. If you want to consider this as a crisis of course comes from geography itself, right? There was a running joke that to choose geography as a major is to postpone your choice of profession by 5 years. And But it doesn't have to be a bad, this crisis is not a bad thing, right? It's an opportunity to talk with other people, build coalitions, learn what you are, lacking, and solve these problems in a somewhat creative and less constrained fashion.
Okay. All right. We have only two minutes to go, and then I just want to each of you give a very short answer to this. And there is a question in here: Should traditional geographer or GIS faculty teach spatial data science? What do you think, Song?
Yes, that's my short answer.
Kreslin said
100%.
yes, 100%.
Absolutely yes, yeah. Even like Anna said, maybe just wear different hats, but yes.
Ilya?
Probably, yeah, I don't know.
Okay, last word
Yeah.
from Lauren.
Yes, and I think that like getting at what Tristan was saying and what Ilya is saying is there's like a piece of this that is like about confidence, right? It's us believing about believing in the contribution that we have to make in these big problems, and like that's the standing up and voicing that, being confident. That's why to me it's important for GIS analysts to see themselves as data scientists, because that's that confidence we need to say, hey, I need a seat at this table, because if we don't think about it through this lens, we're going to be missing something critical. So I say yes, absolutely.
Yes. Okay, we all build confidence together here. This is all the time we have for panel discussion. We would like to say big thank you to all the speakers, all the presenters, as a presenter, for sharing your wonderful experience, insight, advices in teaching spatial data science. We will continue. Okay? We will continue probably in a special interest group during the conference and all the webinar again. So we're gonna do that. And before we finish, I just want to take like 1 minute to just share the resources. So I'm gonna share my screen here. We have a few resources, but the biggest one is the Spatial Data Science MOOC that start in October 27. So it's yesterday we started already and still open. You can register your student or yourself as faculty member, and it will run for 6 weeks, and the content is awesome. So and then you're gonna hear from me in a week from now. I'm gonna send the link to the recording and also all the resources for sure. Okay, and before when you exit, please fill in the survey and let us know if you want to get in touch with us. And many thanks again to Tristan, Song, Ilya, and Lauren for presenting today.